All right, this next one is actually going to go over worksheet number 2 and number 3. So it's good if you have that first page of number 3 sitting right in front of you. And it looks kind of like this because we're going to be reviewing the cardio conduction system. So if you have number 3 in front of you, you have a nice little reference. Or I can just draw it up here. So, well, I guess you could look at the board if you wanted to. But in the cardio conduction system, you have a wave, which is called, this first wave is called P wave. Then you have your Q, R, S, and S dips further. So your Q wave is here, your R is up here, your S is down here, and then you have your T wave. So this is going to be up, and I'm going to be using this for reference throughout this thing. And you can label, it helps if you label this as we go along. So whatever I put on here, just put it on your worksheet number 3. But going through worksheet number 2, can you guys see this okay? Yeah? So the reason why blood pumps through the heart is because of the cardio conduction system, but it's also because of the changes in pressure. So kind of like with the respiratory system, how it goes from high concentration to low concentration. In the heart, it has, in the respiratory system, has to do with pressure of air, pressure of oxygen. Same thing with the heart, except for we're going to be talking about the pressure of blood. So changes in pressure open and close heart valves. So the different changes in pressure are what trigger these valves to open and close. And these actually control like the movement of blood. So there's that. Just some vocabulary. If you look at worksheet number 3 really fast. Did I exit out of it? I think I did. If you go here, depolarization. So depolarization is the electric, what's happening. I'm going to be doing that in black. And then what's in red is like what the muscles do. So you're going to have electricity, muscle action, electricity, muscle action. So whenever you read or hear depolarization, it's going to mean contraction. And whenever you hear repolarization, that's going to be the electric part, repolarization, and this is going to lead to the heart relaxing. So relaxation. So just some vocabulary words that kind of go hand in hand with each other. I'm going to see if I can get that far. I don't know if you can see that. Okay. Well, you can kind of see that. You'll see why it was messed up if you watch this. So yeah, depolarization, contraction, repolarization, relaxation. Kind of go hand in hand. But you have the electric, and then you have the muscle action. So that's kind of the point of this. So going back to worksheet number 2, whenever you hear the word contraction in the heart, we typically, can I get this far? How far am I? Okay. Contraction also means systole. So right, you have systole and diastole whenever you take like a blood pressure. And systole is like 120, so you get like 120 over 80 is the typical blood pressure. Systole is the 120, 80 is the diastole. Contraction, whenever the heart contracts, that's what we call systole or systole. And whenever it relaxes, it's known as diastole. So that's just some synonyms for it. So hopefully breaking down the vocabulary will help us figure out what we're doing, so to speak. So I'm going to see if that actually came in. Yeah, okay, well that's okay. All right, so That's what the number 2 is. So the first heart sound is known as Lubb, and the second heart sound is Dupp. So you hear the Lubb Dupp, Lubb Dupp, Lubb Dupp. The Lubb happens during systole. The Dupp happens during diastole. So that's just some basic vocabulary. Now we're going to talk about the cardiac conduction system, like where are the actual nerves placed in the heart. So in your heart, you have your SA node. Then you have your, this was in the book, but I don't know if you had to memorize it, but just know atrial syncytium. I don't know how to say it. But atrial, right? Atrial, it's in your atria. What is it? Syncytium? Syncytium. Yeah, no, I'm not English. Yeah, but syncytium. Oh, we're going to do that. Syncytium. I like that. But just know atrial. It's in the atria. So just kind of use your keywords. Then it's going to go from your SA node to your atrial something, to your junctional fibers. So you have junctional fibers and you have Purkinje fibers. If you see junctional fibers, it's in your atria. Purkinje fibers are in your ventricles. Just kind of keep that in mind. And typically you'll have a question over Purkinje fibers. These things I think are also italicized in your sheet, which means they're used, but you probably don't need to memorize them. So it goes from the SA node to the AV node, which is kind of right here-ish. So the SA node stands for like arterial node, and that's in your atrias, or in your right atria. And then you have your atrial ventricular node, which is between your atria and your ventricles. And what is the SA node known for? Pacemaker, yeah, pacemaker of the heart. So your SA node says beat, 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 right? And we want that because then we have to think that, and that's just a waste of time and energy. What about your AV node? What does that do? So the SA node says beat. The AV node says slow down. So it's kind of like an equal balance. A lot of the time it's known that the heart has to beat, and if it's not beating, that's a problem. If your SA node is not firing, that's a problem. But another problem in your heart is if your AV node isn't firing, because your heart is made up of an equal balance between contraction and relaxation. And relaxation is what a lot of people don't think of a lot of the time, because yes, we need contraction to push blood out of the heart into the rest of the body, but we also need relaxation so the heart can fill up with blood. Because if we're not filling up with blood, then we're just pumping out nothing. You know, it has to relax, then it has to contract. So the AV node is really important for relaxation of the heart. It kind of tells the heart to slow down, because if the heart's able to slow down, it's able to fill. So that's the importance of the AV node. Next, we have the AV bundle of His, which kind of descends down into the heart. That's pretty much that. You have your bundle branches, which then branch to your ventricles. And then you have your Purkinje fibers, which are kind of branching as well. So I bet your anatomy book has a better picture than I can actually produce. Oh, thank you, applauded. So as far as I know, everything that I had you kind of fill in is what instructors like to ask about. So just kind of keep that in the back of your mind too. But yeah, so this is how it happens. The SA node fires, goes to the AV node, and it goes to the rest of the heart. So it's kind of like, I think about like milking the cow. You know, you start here and then you go here. So your atrias contract first, because that's where your SA node is, and then your ventricles contract, because that's where your Purkinje fibers are. So it's going to contract, contract, if that makes sense. So, okay. So that's the whole, oh, here we go. Number 5, is the pacemaker of the heart? Well, our SA node, pacemaker, it sets the pace, it tells the heart to beat. It stimulates the heart to contract. And what node delays the impulse? And this is the AV node, which is important because we need to delay that electric impulse in order for that heart to fill up with blood.
It kind of regulates
the
conduction.
Yeah, it regulates.
The SA node fires it starts it, and then that AV node kind of controls that.
Yeah, it kind of says, like, okay, we're going to, yes, we will use this electric contraction. No, we won't use that. Yeah. So the AV node is the smart node. I like my AV node. So just, number 7, rule of thumb. Whenever a heart is relaxing, it is filling up with blood. And whenever a heart structure is contracting, it is pushing out blood. It is squeezing blood out of it. So I'm going to, So blood out for contraction, for relaxation, blood fills the heart. Does that kind of make sense? Okay. So I'm going to erase this conduction system. And we're just going to focus on how blood kind of flows with this gram over here, this cardiogram. So. Okay. So now we're going to fill in the blank. And on this side, you have your own little boxes on the side, and that asks for your P wave, your QRS wave, and your T wave. So this first one, we're going to talk about the P wave. So the sequence of the cardiac cycle occurs when the AV valves are open. So these are the AV valves. Remember the arterioventricular valves, arterial meaning, or your atrioventricular. So your atria and your ventricles, that's what these are. So your AV valves are open and your semilunar valves are closed. Okay? And typically, we're just going to talk about one side, but this happens on both sides of the heart at the same time, but we're just going to do the one side. So oh shoot. That's not that color. So you have deoxygenated blood in here, in your right atria, from your superior inferior vena cava, okay? Atrioventricular valve is open, so it's going to drip for a little while into your ventricle. Okay, this is direction. So it's kind of like with gravity. It's just going to drip for a while. So AV valves are open, semilunar valves are closed, and we want this closed so blood can collect right here. 70% of blood flows passively from the atria to the ventricle. So that's what this is. It's kind of flowing passively. I think about it in terms of gravity. It's kind of like dripping, flowing, whatever you want to say. And then when the pressure of the ventricles increase, so just say it fills up with a lot of blood, and this pretty much leaves the atria, 70% of it does, then it's going to trigger your SA node to fire. And that's what's going to start everything, is when your ventricles are full, because the SA node tells your heart to contract, and when your heart contracts, that's going to push blood out of the heart. So your ventricles are full, and they're like, hey, I'm full, I need to get rid of this blood. SA node, you need to fire. So the SA node fires. This first step is known as atrial contraction. So your SA node is going to fire. Your atria is going to contract. So when it contracts, it kind of squeezes. And it's going to push all this blood into the ventricle. And I probably should have said this at first. So when this SA node fires, you're going to have the electric, and then you're going to have the muscular. So you're going to have your P wave, which indicates the P wave just kind of detects what's going on electrically in your heart. So the P wave indicates your SA node. So your P wave is going to happen, and then the muscular action is your atria are going to contract. Does that make sense? So you have your P wave, which detects your SA node, and then your muscles are going to contract. So electric, muscular, because the electric system controls everything. So that's kind of what happens with your P wave. With atrial contraction, just know ventricles are relaxed, okay? They're relaxed, they're able to fill up with blood. So your ventricles are relaxed, they're filling. The atria contracts, and just know that the AV valves are open, semilunar valves are closed. And they're closed because we want blood to collect in your ventricles. So, any question about atrial contraction or why the atria contract? Okay, so that's that event. The next one we're going to talk about is ventricular contraction. So what's going to happen is, right, we had our SA node, we had our AV node, and then we had our bundle of His. The electrical impulse is going to travel throughout the heart from the atria to the ventricles. It will be detected as the QRS complex. So you're going to get the detection of QRS, electric impulse, and then your ventricles are going to contract. So going through ventricular contraction, the ventricles are now full, okay? They're full, they are ready to be emptied, so the ventricles contract. And when the ventricles contract, you can look at the board, but what happens to the valves? Which one's closed, which one's open?
Semilunar valves are going to be open.
These are going to open. And then
Ventricular valves are closed.
and why are they closed? Yeah, so if your ventricles contract, you don't want blood going back into your atria. So your atrioventricular valves are going to close. Your semilunar valves are going to open so it can push deoxygenated blood to your lungs. So that's ventricular contraction. We're going to push blood, and blood is going to leave and go to your lungs. Okay? The AV valves snap closed due to chordae tendineae. That's what the fibrous tissue is known as. And when those atrioventricular valves close, when you hear them close, and this is happening on both sides, I'm just not drawing blood flow on this side. That's what you hear when you hear Lubb. You hear the Lubb Dupp whenever you listen to a blood pressure. That's because you hear the valves opening and closing. So the Lubb is your atrioventricular valves closing. That sound, that's your Lubb. So pretty neat, right? We're just listening to our valves. Yeah, and then the semilunar valves are open, so we can push blood out. So, and then blood leaves the ventricle, right? It leaves the ventricle, goes through the pulmonary circuit, also known as, but this particular vessel is known as the pulmonary artery. Yeah, no, you're good. So yeah, that's what'll happen. It'll leave through the pulmonary artery. It'll then go to the lungs. Do you guys have all this written down? Okay. So when blood, we're just going to kind of take a pause. Blood is going to come to the lungs. Blood is oxygenating, right? And that's great. That's wonderful. We want our blood to do this. Okay. But the thing is we also, in our heart, we need our ventricles to relax so they can fill up again, right? So something that's interesting when you look at this, you have your P wave, your atrias contract, you have your QRS wave, your ventricles contract. Then you have your T wave, which indicates your ventricles relax. So when you're looking at this, what is missing? Your ventricles contract. Right. So where would atrial relaxation be? Atrial relaxation happens at the same time as a QRS complex. So it kind of looks like this. But the thing is, because the ventricles are so massive and because you need a lot of electric impulse to make the ventricles do something, it's kind of hidden. You don't see it. It's not detected. So when your ventricles contract to push blood out, your atria relax. This is showing like they expand. So it's kind of like when one contracts, one relaxes. That's how your heart works. So contraction, relaxation, contraction, relaxation. It's kind of opposite. If you look at
like hitting a big drum and a tiny drum at the same time.
Yeah.
You're not gonna hear the tiny, sort of.
Yeah, like hitting a big drum and a small drum at the same time. That's a good way to go about it. If like the atria is like the small drum, you don't hear it because the big drum is, I'm a ventricle, I guess. So the atria relax, and when they relax, they fill with blood and they do their own thing. But what we want to focus on is ventricular relaxation. So your blood is over here, it's fine and dandy. That's great, we're just going to ignore blood from now on. So your atrias, when your ventricles pump blood out, your atrias are going to be collecting with blood at the same time because they're relaxing, they're opening. So when they relax, they're going to collect blood at the same time as your ventricles are pushing blood out. Okay? So you don't really see that with your atria, but now we're going to have ventricular relaxation. And with ventricular relaxation, the ventricles are now empty. They're going to relax now because they're empty, and they're saying, hey, now we need more blood. So they're going to open up, they're going to relax. When your ventricles relax, the semilunar valves are going to close. And we want them to close so blood can pool inside of them. So when this happens, your AV valves are then going to open up, and then blood will once again flow passively into your ventricle from your atria. And when your semilunar valves snap closed, that's the Dupp sound. So you get the Lubb, Dupp, Lubb, Dupp. The Lubb is when your atrioventricular valves close. The Dupp is when your when your semilunar valves close. Does that make sense? Okay. And then the whole thing starts all over again. The AV valves open up so it can drip. Semilunar valves close. 70% of blood flows passively from the atria to the ventricle, and then pressure from the ventricle increases. When this pressure increases, it'll stimulate the SA node to fire. When the SA node fires, it'll cause the ventricles to push blood out once again. So, do we want to run through this a second time? Because that's what the other half of this worksheet is.
Sure.
Yeah? Okay. Yeah. Okay, so we're going to go to worksheet number 2. This is worksheet number 2. And we're going to include both sides. So we're going to start from the top, because I may have to. And I'm going to incorporate both sides of the heart now so we can see how that kind of both works. So again, You're going to have electric impulse. You're going to have a muscular impulse. The electric impulse is going to mean depolarization or repolarization. Depolarization means the heart will then contract. That's the muscular action. You have electric, then you have muscle. Repolarization occurs, and your muscles are then going to relax. Whenever you hear the word contraction, that's kind of when your heart squeezes. Contraction also means systole or systole, however you want to say it. And whenever contraction happens, we're going to squeeze blood out of the heart, go to the rest of the body. Relaxation, also known as diastole, is going to have the heart's going to relax so it can fill with blood. And that's important because we need to have an equal balance of filling with blood and emptying blood. So that's just a brief little thing. So we're going to do both sides of the heart now. So if we take that last step, AV valves are open, right? And the semilunar valves are now what? So your semilunar valves are closed. Okay? Naturally, so in your right side, you're going to have deoxygenated, but in your left side, you're going to have oxygenated. So 70% of blood flows passively from the atria to the ventricles. So it'll flow, it'll flow, it'll flow. And then when your ventricles get really full of blood, your ventricles are going to get a lot of pressure. And when they get a lot of pressure, they're going to tell the SA node, you need to fire. So the P wave detects that SA node firing, and this will cause, so you have your electric and you have your muscular. The P wave detects the electric portion, and then your atrias are going to contract. So they're going to contract. And this is showing like arrows pushing in. So your ventricles are relaxed because they're filling up with blood. That's what this next thing is. Your atrias are going to contract. Over here you have your P wave. So you have your P wave, then you have your muscular action. So your atrias are going to contract, and they're going to push blood out, and blood is all going to flow. Oops, shoot. And it's going to fill your ventricles up. And remember, AV valves are open. That's what these are. These are AV valves. Your semilunar valves are closed, and they want to be closed so we can let blood pool. So when the atrias contract, when they push blood out and your ventricles are relaxed, what is the next step? Remember, it's like milking the cow, right? Your atrias are going to contract, and while your ventricles contract, your atrias are going to relax. So you're first going to have the electric impulse. You're going to have your QRS complex, and that's going to trigger your ventricles. These parts of your heart, your ventricles are then going to contract. But at the same time as your ventricles contract, there's a little bit of an electric impulse hidden, and your atria is going to relax. So this happens at the same time with your QRS complex. So it's kind of like, so this first step, when your atria contract, your ventricles relax. Now your ventricles are going to contract to push blood out, and your atria is going to relax. So it's kind of like this. So your atria is going to open, or going to relax. Your ventricles are going to contract. Same thing on this side. And we want them to relax so they can fill up with blood. So that's going to happen. So during ventricular contraction, we have our QRS complex, which is the electric portion of it. When the ventricles contract, the atria is relaxed at the same time. When the atria is relaxed, it becomes filled with blood from the superior and inferior vena cava. So over here, it'll become filled. And then on the left side, it's going to become filled from the pulmonary veins, which are over here. So blood is going to come up over here, and it's going to fill it. So that's just something to keep in mind. So the ventricles are now full. This is what we're going to be focusing on. They need to be emptied. So your ventricles are going to contract. And when your ventricles, so they're full now, no longer. When your ventricles contract, your AV valves are going to close. And when your AV valves close, it's to prevent blood from going back into the atria, because we want blood going out. We don't want it going back in. The atrias are already filling from your vena cavas. They're already filling like this. So we don't want blood going back out. So blood is going to, your ventricles are going to contract, and this is going to push blood out through the semilunar valves, lungs. And this is going to go to your body. Okay? Your AV valve snap closed. That's that Lubb sound. So you hear Lubb, Dupp, Lubb, Dupp, Lubb, Dupp. That's your valves closing, the Lubb, the first sound. This is due to your chordae tendidae. The semilunar valves are going to open so the heart can push blood out through it. Does that make sense? Okay. Next thing you're going to have is your, so because our atria are now filled, blood goes to the body successfully. We like this. Blood goes to the lungs successfully. We like this. So blood is where it needs to be. Now we're going to look back at the heart. In order for it to contract again, your atrias need to contract and your ventricles need to relax. So what's going to happen is your ventricles are going to relax. When your ventricles, because they're now empty and they need to be relaxed so they can fill up with blood. So when your ventricles are relaxed, your semilunar valves are going to snap closed, because they're going to be like preparing for blood to flow back through. So they're going to be closed. And this is your Dupp. So you hear Lubb here, and this is your Dupp, is when they close. So when this one closes, it's Lubb, then you hear Dupp. So this is the step we're focusing on. It's the Dupp step. So your AV valves are then going to open after your at the same time as your semilunar valves close. And these are filled with blood. And then we're going to have kind of from the beginning, same thing. And the thing that stimulates your ventricles to relax is your T wave. So you're going to have your T wave, and then you're going to have your ventricles relax. So you have your T wave, and then this happens. Last thing, your AV valves are open to allow blood to flow passively, kind of like gravity, to flow passively from the atria to the ventricle. 70% of blood flows this way passively. Pressure in the ventricle is then going to increase. Because of all this blood, it's going to increase. And then the SA node is going to fire, squeeze the atria. Blood is going to then go from the atria to the ventricles. And then it restarts over and over again. So if you look up an animation, hopefully this, taking it step by step, you can look at it and define what's going on. Do you have any questions? Oh, did I scroll too fast?
Just one bump.
Just which? Right after the P wave?
Yeah, just one big one.
Which one?
I guess it's right here. So the atria becomes blank when you reach that goal.
When the atria what number is it?
On page 4.
Okay. This is page 5, page 4. Page 4. Let me come over to you. When the ventricles and atria relaxes at the same time. When the ventricles contract, the atria relaxes at the same time. When the atria is relaxed, it becomes filled from the superior and inferior vena cava, and the left atrium becomes filled. That's what this is. It becomes filled from the pulmonary. Yeah, here it is. And the left atrium becomes filled from the pulmonary veins. So that was just showing it a second time with both sides of the heart. Yeah.
Pulmonary vein is different with others because it's
Yeah.
with the oxygen. With
Yes.
oxygen blood. It's not really like others, the vein with like deoxygen.
Yeah. So a good way you can think about it is if blood flows away from the heart, it's an artery. So yeah, but typically, usually arteries are oxygenated when they go to other parts of the blood, or other parts of the body. Whoops. But you're right, the artery does carry deoxygenated. Yeah. Yeah. So it's like, whew, it's quite a stretch, yeah? But do you guys understand that the electric and then the muscle, that's how that works?
It's finally like looking at this makes sense now. Okay.
Oh, this is what the heart does. And I don't think you need to memorize each step of it. I mean, in advanced anatomy, this is kind of more so what it goes into, but this is just for like understanding. Like, and the better you understand this now, the better off you'll be in your other medical professions.
Yeah.
So,
You have to like keep rereading this stuff. Yeah. So like school starts again.
oh yeah.
I forget it all.
Well, that's what the worksheets are for. They're good review.
Absolutely.
So that's that.
I like to quiz my boyfriend just to see like what he knows. And he actually like he gets it pretty well. It's like, okay, I can't see. It's like, good try. Yeah.
Yeah.
Right.
Well, that's a good way because when you teach other people, then you kind of learn it yourself. So, all right.